Hello and welcome back to my YouTube channel. In this video I will be going through the exam questions that were posed in my previous video. The first question was, draw the logic circuit diagram for the following expressions. Z equals not A or not B. As you're aware, we always start off with the brackets first, so we start off with the not A and then the not B gates as shown below. So we've got not A and not B. And then we know that we've got an OR gate which is going to be outputting the value Z. So we add our OR gate and we just join them together. Nice and easy. Now we're going to look at the second expression, Z equals A and B or A and C. As mentioned in my previous video, you always do the brackets first. So here we will be doing the AND gate and then the second AND gate and then outputting the value Z from the OR gate. As you can see from this expression, we have A and B or A and C. So we know that A from both AND gates will be combined and then we'll have an input B and C. And in total we will be having three inputs which will be A, B and C. So let's get started with the AND gates first. Add your AND gates and add the inputs. As you can see here, input A is being shared by both AND gates. The next step would be to add in our OR gate and the output Z and then join them together. Question 3. A system controls the flow of vehicles through a barrier based on three lights, A, B and C. When a light is red, the signal is 0. When a light is green, the signal is 1. The barrier will open when the output X is 1. The barrier opens if either light A is red and light B and C are both green, or light A is green and light B and C are both red. Create a logic circuit and produce a truth table. Before creating the logic circuit, I would recommend you to simplify this statement. So in order to do this, let's go through it again. It's telling us light A is red, where A is equivalent to 0 when it's red, and lights B and C are both green, meaning 1. So in our truth table or on top in your exam, you can actually write down 0, 1, 1, and if that's the condition, it tells us in the statement the barrier will open when the output X is 1 if either of these conditions are met. So we've got 0, 1, 1, which will raise the barrier, so the output will be 1. The second condition tells us light A is green and light B and C are both red. So we've got 0 in B, 0 in C, and then the output would be 1 also. Now let's break this down even further. So to do this, we actually know now X is equal to 1 when A and not B and not C are input into the logic circuit. So we can actually write this down as X equals 1 if A and not B and not C. This is how it will look when it is expressed even further. If A and not B and not C, then we've got the other option, which is or not A and B. So that will be expressed as not A and B and C. So now we know that A and not B and not C will equal to 1. So this actual first set of brackets is telling us the logic gates that we will be needing in order to make this statement. So it's telling us that for input A we need an AND gate, for input B we need a NOT gate, and for input C, we need another NOT gate, and to join both input B and C together, we would use an AND gate, and then to join that AND gate to input A would be another AND gate that is used. So let's look at this. So in your exam, you will be provided with the inputs and outputs. So the first part of our logical expression is telling us that A and, so input A would go through an AND gate, then not B, so input B will go through a NOT gate, and input C would also go through a NOT gate. And then we need to connect input B and C together with an AND gate and connect that AND gate to the AND gate of A. As you can see here, we have the first set of brackets done. For the next step, you could either do the OR gate, which will output the value X, or you can actually start with the second set of brackets. I'm just going to look at inputting the OR gate into my logic circuit just to show you the output for the first part. So as we mentioned earlier, X will equal 1 if and not B and not C. OR. So as you can see, the OR is joining the two statements together. So what would happen here? The output from this AND gate will go into an OR gate. Now looking at the next part here, not A and B and C. So we can see here, A will be going through a NOT gate. So as you can see here in the logic circuit diagram, not A. Then we've got B and C. So we've got B going through an AND gate and C going through the same AND gate. Now we've got an AND here joining not A and B and C. So that means we need one AND gate that will join the not A and the B and C logic gates together. So here we would insert an AND gate and then join that to the OR gate. Once you've completed your logic circuit, the next step would be to actually test it with the following inputs. But before we do that, I'm going to quickly complete our truth table and then we can go on and test it to see if it works as it should. So what we need to do next is put in all the different combinations of the inputs and outputs. We know that the output X will be 1 only on these conditions. So we actually know that all of the other outputs will be 0, but we need to put in the different combinations of inputs. So 1, 1, 1 will be equal to output X as 0. 1, 1, 0 is also 0. 1, 0, 1 would be 0. 0, 1, 0, 0. 0, 0, 1, 0. And 0, 0, 0 will output 0. So now let's look at testing this theory that we've been given. So the first statement that was mentioned to us was if input A and not B and not C will output 1. So let's put that into our logic circuit, 1, 0, 0. If 1 goes in here, we'll need another 1 going in from this AND gate. As we're putting in 2 zeros, these will turn into 1s, and in order for an AND gate to be true, both of its values need to be true. So we do meet that statement. So the output from this AND gate would be 1. And as you can see here, both of the inputs into this AND gate are 1, so the output would be 1. Now, this is an OR gate, and we know that either of the two values need to be 1 or both in order for the output X to be 1. So we've actually matched this statement, but let's see what's happening on the other side here. So we've got A, not A. So if we put in a 1 to this NOT gate, it's going to be a 0, whereas B and C are going to be zeros, as both inputs need to be 1 in order for the output to be 1. And as you can see here with this AND gate, the value that will be output from this would be 0, as both values are not 1. So we actually do meet our first condition. Let's check our second condition now. So 0, 1, 1. So if we put in a 0 into this AND gate, we actually know that a 0 will be coming out, as both of its inputs need to be 1. When we put a 1 into the NOT gate, it would return a 0, and same again with input C. If it goes into the NOT gate, it will return 0. So we actually know the first half of our logic circuit will return a 0. Let's look at our second part. So if we input A as a 0, it will go into our NOT gate and return a 1. B going into our AND gate will return a 1, as C is also a 1. So both of its inputs are 1s, and in order for the AND gate to be true, both inputs need to be true. So that will return a 1, and that going into our OR gate, either one of the values or both values need to be 1 in order for the output to be 1. So we actually meet our second condition now. Also, you need to ensure that your logic circuit meets all of the other conditions too in order to attain full marks. Let's look at the next question now. 3 switches A, B and C send values of 0 or 1 to a logic circuit. Value X is output from the logic circuit. Output X has a value of 1 depending on the following conditions. Switch A sends value 1 and switch B sends value 0, or switch B sends value 1 and switch C sends value 0. Create a logic circuit and produce a truth table. Your first step will be to break the problem down. So we know X equals 1 depending on the following conditions. When A is 1 and B is 0, or B is 1 and C is 0. So we know X equals 1 if A and not B, as B is 0, or if B and not C. I would recommend you to simplify your problem in your exam, as it will save you a lot of time. So what we can see from here, X equals 1 if A and not B, or B and not C. So we can see that we have 3 inputs, A, B and C. So let's get our inputs in and our output X. The first thing we're going to do is the first set of brackets. So it's telling us A and not B. So this means A will be going through an AND gate and B would be going through a NOT gate. And then B would be joined with A through the AND gate. So as you can see here, we've got A going through an AND gate and then B going through a NOT gate, which then is joined together for B to go through the AND gate. The OR gate joins both of the statements together. So we'll leave this for now. We'll come back to this near to the end. The next step is to look at B and not C. So we know that input B is going through an AND gate and input C will go through a NOT and then join with input B via AND gate. So let's have a look at this now. So B would go through an AND gate and C will have a NOT gate joining onto this AND gate to produce an output here. Now in order to do the final part, all you need to do is insert an OR gate. As I mentioned earlier, the OR gate is connecting the 2 statements together to produce the output X. So what we do is insert the OR gate and just connect it together, and there you have it. The next step for you would be to produce a truth table. So as you can see from the statement, switch A sends a value 1. So that's saying A would be 1 and B would be 0 in order for the output X to be 1. There's no mention of input C, so that means that input C could be either 1 or 0 for this first condition in order for output X to be 1. So let's start off with having input C as 1 and the value will equal to 1. On the next condition, it will be again, sends value 1 as input A. Switch B sends a value 0 and input C this time would be a 0. And the output for that should also be 1. The second statement states that switch B sends a value 1. So this time we're looking at input B column. So it sends a value 1 and switch C sends a value 0. So input C should be a 0 for the output to be 1. So that means input A could be either 1 or 0 in order for the output for this particular condition to be true. So 1 and output X equals to 1. Now let's look at the other one, the other alternative with input A being 0, input B being 1 and C being 0. So input B 1, input C 0 and input A as 0. So we've got the two different combinations there for the second logical statement, and the output would be 1. So the next step will be to add in all the other combinations, and we know now only these 4 combinations would output 1. The other combinations such as 1, 1, 1 would output 0, 0, 1, 1 would output 0, 0, 0, 1 would output 0, and 0, 0, 0 would output 0. So these are the 4 possible combinations where the value can only be true. The final step would be to actually test your logic circuit to see if it outputs the correct values. So we will start off with the inputs 1, 0, 1, and the output should be 1. So we've got as input A, we've got 1, B as 0, and C as 1. So as we can see here, we've got an AND gate, and we know that both of the inputs from an AND gate need to be 1 in order for the output to be 1. So we've got a 1 already going in. From B, we input a 0, and that will go through the NOT gate and turn into a 1. So we've got 2 1s going into the AND gate, which will output another 1. And that going into the OR gate, now we can see here OR gate, either value needs to be 1 or both values in order for the output to be 1. Let's see what's going on here at the bottom though. So B and C, if 0 goes into the AND gate, we know now that will be a 0 as an output, as both B and C need to be 1 in order for the output to be 1. So we've got 1 going in from C through the NOT gate, becoming a 0, so 2 zeros output a 0, and 1 0 going into the OR gate will return 1. The first statement was a success, so now it's time to look at the next statement. So 1 0 0 should output 1. So let's put in 1 0 0. So we have 1 going into the AND gate, 0 going into the NOT gate for input B will turn into a 1. 2 1s will output a 1 in an AND gate, and a 0 going into the AND gate that is shared by input C, where C would input a 0, which will turn into a 1, and going into that, a 0 and a 1 into an AND gate will return the value 0. In the final part, as we mentioned earlier, both inputs need to be 1, or either one needs to be 1 for the value in an OR gate to be 1. The second condition was a success, so now let's move on to the next one. 0 1 0. So input A would be 0, input B would be 1, input C would be 0. So we know, again, for the AND gate to be true, both inputs need to be true. We have 0 going in. From B, we have 1 going into a NOT gate, which will return a 0. So 2 zeros will output a 0 in the AND gate. For the second part of our logic circuit, for B, we have 1 going into an AND gate with the C input as 0, which will return a 1. So 2 1s will return a 1 in an AND gate, and either of the values or both need to be 1 in order for output X to be 1. So we have also met our third statement.